just went to correct the date and I just typed 24 in again. I went to erase 24 and then retyped 24. The 30th, right? Mm-hmm. All right. So I know we still got people coming in here. So let's start with a couple more quiz questions and common questions I've been getting from people before we get into more practice with conversions. Somebody asked me this. I thought this was a really interesting question. What is something I wish my chemistry teachers had done? And that was kind of tricky because I kind of always liked chemistry just because it was hard. I liked it because it was a challenge, and so I was always kind of interested in it just for the sake of trying to solve problems. But one thing I do specifically remember is not making any sense was the labs, in Gen Chem especially. And I remember them specifically never making any sense or like connecting to the lecture material at all. And so I don't know if I just understand the chemistry better now, and so I think my labs are connected to the lecture material, or I've actually done a better job than my teachers did at connecting it to the lecture material. And I'm not fishing for compliments, so tell me if you don't see the connection, that's fine. And there will be some times where we have to learn some techniques in lab, and the techniques aren't really related to what we're covering. But for the most part, I try to make the labs kind of match up with what we're covering, so it's more of practice and kind of solidifying things, like using density as a conversion, right? That's something we worked on in class, and then we saw it in lab as well. Somebody else asked about how much time you need to spend outside of class to be successful. That's also going to depend a lot on your background and how prepared you are for this class in terms of do you understand algebra, or are you behind on algebra? If we're trying to catch up on some of that stuff, then it might take you longer to finish some of these assignments and things like that. So it's a kind of a hard question to ask. There was a lot of time in class for this class though, right? You guys get to meet with me for labs twice a week. If you take advantage of that and you come to the lectures and you participate and work on the practice problems and lectures, someone could conceivably spend very little time outside of class and still get a good grade in this class. That said, there's always going to be some stuff, like for instance, we did the in-class assignment this week. Almost nobody got started on that in lab today, right? If anybody did. I don't think anybody today did. We'll have a little bit of time to work on that in lecture today instead, but like there's going to be some spillover when you don't finish assignments. You're going to have to finish them outside of class, and there's some studying that's going to have to happen outside of class, of course. So it's hard for me to put a number to it because it's going to depend on everybody individually. But there's no, let's see how I can phrase this. You probably don't need to be spending 15 hours a week on this class outside of class. Like, put that as like a cap. That sounds like an absurd number, but you actually count up all the time you spend studying outside of class, you might get close to that. That's probably too much. But you're going to need to spend some time. Almost everybody's going to need to spend some time outside of class. Whether it's 2 hours a week or 6 hours a week, depends on you personally and how fast you are and what level you want to understand the material. The other thing I will also reiterate is now that everybody has shown to me that you know how to turn things in online, by turning in your math review online, I'm not going to be super picky about whether you turn stuff in on paper or on Canvas or some mixture of the two. All right, so I have a pretty good track record for not losing papers. That said, if you're worried about that, or you want to keep a copy of, say, your in-class assignment so you can study from it for the conversion part of the midterm, turn it in on Canvas. I will grade it and give it back to you, but it might not be for 3 weeks. So if you want to study from something, or if you want to keep it, I would turn it in digitally. And if you're turning it in late, I would really turn it in digitally, because late assignments are the ones that get lost. Because if I've got a stack in my office of paper labs, and then you hand me one by itself up here, and I just happen to leave it when I'm grabbing my stuff and never see it again, like it's not with the rest of them. I never do that with a whole stack of papers, but I might do that with one paper by itself. So if you're turning in something late, it's best to do it on Canvas. All right. And yeah, you can mix and match with that too. So assignments that have an Excel piece and a paper piece, you can turn in the Excel online and then the paper on paper. That's totally fine too. I have to sit down and grade them all at the same time anyway, so it doesn't really matter to me if it's on paper or Canvas. And then last but not least, a random question. What about AI? AI is weird. AI is really weird to us. AI doesn't think like us. I think this is kind of not the right question, maybe. I think is AI conscious might be the right question. Yeah. Because living, there's lots of things that are living that aren't conscious, right? Conscious, in its really rough definition that I'm coming up with off the top of my head, is being something along the lines of being able to understand how the universe works outside of themselves in their immediate environment. And so it's not a binary state. It's not on or off, right? Dogs are more conscious than bacteria, but they're not as conscious as apes. So is AI conscious? It's probably getting close. In sci-fi, they always call it the singularity or something like that. Like there's some moment where all of a sudden AI achieves consciousness. It's probably not going to be like that, but it's interesting because it definitely is capable of measuring things and predicting things about the universe in a way that's kind of human-like. So I thought that was an interesting question. And consciousness itself is kind of a weird thing, right? So it's just a collection of atoms that are capable of understanding how other atoms work. Is really what consciousness is. And with that definition, all of a sudden AI might be even closer to consciousness. I don't know. Depends on who you talk to. I will say that people as far apart as Elon Musk and Stephen Hawking have both said that they think artificial intelligence is the single biggest threat facing humanity after climate change. So it definitely has the potential to go sideways for humans if that does happen. But there's a really interesting, if you're interested, send me an email or something on Canvas. There's a really good blog written by a guy who's known for taking complex ideas and breaking them down. And he talks about why AI might be a problem not from a practical standpoint, but from a basic, well, why would AI care about humans? It's not like out to get humans. It doesn't have to be out to get humans in order to destroy the planet.
What's the blog called? I asked this question.
What's that?
What's the blog called?
Wait, but why? Let's see, I think that's it. Yeah. So it's pretty good. It goes through how technology works in general and why artificial intelligence is a little bit different and why it's scary for humans as well. All right. With that, I won't say out of the way because I always enjoy random conversations like that. But let's talk about what do we do with higher powers of units. What I mean by that is to have areas are usually area units are usually length units squared, right? Because the simplest way of defining an area for a square is length times width, right? Or a distance times another distance. So that means our units are going to start being weird a little bit because all of a sudden we don't have just centimeters and inches, we have square centimeters and square inches. So if we want to convert inches to centimeters, we know how to do that. If we want to convert square inches to square centimeters, the same basic process works, except we have to do it twice. Right, so if you think about converting 1 square inch into centimeters, well, if it's a 1 inch by 1 inch box, you have to convert both sides of that box to centimeters, and then you could do length times width, right? Or in other words, you can take this and 1 inch is 2.54 centimeters, right? So in square inches, we wind up with 1 times 1 to get 1 square inch. But in square centimeters, it would be 2.54 times 2.54, which is something like 6. So we have to convert both sides of this in order for this to work. If you have a nice, neat box, then that's fine. You can just convert the units, the dimensions of the box before you do length times width. Or even if it was a circle. You had a circle with a radius of 1 inch. If you want to know the area in square centimeters, you could convert 1 inch to centimeters and then put it into pi r squared, right? Well, we don't always have nice, neat geometric shapes. So we need some way to convert these units that's not reliant on using geometry. And so the way we can do that is we just convert both sides of the box in a conversion. Instead of doing 2 separate conversions, we write it as, if we have 1 inch squared, that's the same as saying 1 inch times 1 inch, right? Or 1 inch times inch. Well, if we're trying to cancel out inches to get to centimeters, we've got to cancel out both of those, not just one. So that means you have to do the same conversion twice. That would cancel out one of these, and then we would have to do it again, right? Now we can say inches cancels inches, and inches cancels inches, and we get centimeters times centimeters for our units. Right? So we don't usually write it out like this. We don't usually expand these. If you have anything in area units, though, any of our regular length conversion still works. You just have to do it twice. You just have to square the conversion factor. Because when you square a conversion factor, you square everything inside it. So you get 2.54 squared, centimeters squared, inches, or 1 squared, and inches squared. So we can write it in a really simple way by just doing it like this. You just have to remember that when you distribute the squared, it doesn't just go to the units, it goes to these numbers as well. Right, so easy enough when we're dealing things like 1 inch, right? What if we have a piece of property that's listed as being 2,552 acres? Let's first off, actually, let's say how many square feet is it? And then we'll go from square feet to square miles. So if we have a definition of an acre here that goes acres to square feet, our first conversion is pretty straightforward. Nothing's different about it because this is just sort of straight ahead. 1 acre is this many square feet. Right, so you could say 2,552 acres. 1 acre is 43,560. So an acre is already a unit of area. We have acres to square feet. So we're going to get something in the 10 million range. Maybe closer to 100 million. He's working on it. What do we get, Bella?
111 million
111,000,000.
165,120.
Keep 4 sig figs. That's going to be 10 to the 8, right? 10 to the 9 would be a billion. So if we want to take that and turn it into square miles, because that's just a dumb number in terms of square feet, right? Square feet's great for measuring things like the size of one room. It's not great for measuring things like when you get into the 100 million range, right? So if we want to put that in square miles, well, we don't have a conversion for square feet to square miles. We have a conversion for just feet to miles, right? Right. And we can still use that. We just have to do it twice. So 5,280 feet is 1 mile. We do that twice. Get something like 100 square miles. 200. I put 4 sig figs on there, and I can't carry 4 sig figs in my head when I'm doing this. What do we get?
Did I do it right?
You may have, and I just totally botched it in my head. I'm doing it in my head by saying, well, that's 10 to the 8. This is 10 to the 3, and I'm going to square it, which is going to make it 10 to the 6, roughly. So I should come up with something in the hundreds ballpark.
Yeah, something like
400 or 4 square miles.
4 square miles.
Yeah.
Like
That's what I
3.9875.
Yeah.
Okay.
Sounds like you confirmed it too.
I guess we do have the additional tens place that we get by squaring 5. So that would take it down. Yeah, okay. When you're trying to use scientific notation to do arithmetic in your head and squares are involved, sometimes I'm off by a couple factors of 10. Does this make sense in terms of what we know about everyday life? So, not everybody knows what 1,000 acres looks like, but 4 square miles is a pretty big area, right? Think of a box that's 2 miles by 2 miles. I wouldn't say it's out of the realm of possibility. So I don't think that you did it wrong necessarily. And if you're ever not sure if you put it in as a exponent properly, you can always do it in pieces. So I was not able to show you Wolfram Alpha the other day because the internet was down when I was trying to explain how to use this. But if we had 1.114 e to the 8 over 5,280 squared at 3.9959. So a little rounding difference, but that's fine. I might have just heard a number wrong. And when you plug it in on Wolfram Alpha, it will also give you the
I took the
graphical and
I took the direct number from.
Oh, okay. I rounded
so,
and you didn't. Yeah, that'll do it. Yeah, absolutely. And if you want it to show the conversion factor, you can even plug it in as 1 over 5,280. When you plug it in, it should give us, there's our graphical interpretation. It doesn't do units the same way. It will just, if you just plug in the units and ask it to convert, it'll do that for you too, but it won't show you the work. So that's not going to help you when it comes to a test. But you can, Wolfram Alpha is a pretty good use if you don't have a calculator handy, but you have internet. This works pretty well. So if we wanted to turn this number into square meters, there's a couple ways we could get there. from here. We could either start from square miles and go to square kilometers and square kilometers to square meters. Because we know we can go from miles to kilometers if we have our conversion sheet in front of us, right? And we also know we could go the other way. We could go from feet squared to inches to centimeters squared, centimeters to meters. Either way, it's still all length conversions. We're just doing them twice. So, and they should give us the same number when we do that. So you go feet squared to inches squared, centimeters squared to meters squared. Or you can go, since we have it in miles squared, and we only need 4 sig figs, we have a conversion on our conversion sheet that does miles to kilometers, which means we can do miles squared to kilometers squared, and kilometers to meters. If we wanted even more sig figs, this is the way to do it, because this is all exact conversions still then. If we only care about 4 sig figs, this is 1 step shorter. 1 step's not the end of the world either way, though. And if you don't have that miles to kilometers conversion memorized, you probably have all these ones memorized by now, right? Once you add 2.54 in there, the rest of these you probably already knew before you got here. Centimeters to meters is 100. Centi, Latin for 100, like percent or cents in the dollar. Yeah, so either of these would work. Go the exact way for the sake of showing it more than once. 1.114 10 to the 8 feet squared. Feet to inches. Well, 1 foot is 12 inches. Do it twice. And 1 inch, 2.54 centimeters. Twice. Then 100 centimeters, 1 meter. Twice.
And you're just doing it twice just to get rid of the square, right?
We need to convert both sides. If you think of this as being a square, you need to convert the length on both sides of the square, or both powers of the unit. And if we went the other way, we could just be in 3.998, 988, according to what I have written up here, so I'll be consistent with my numbers. Miles squared, 1 mile, 1.609 kilometers squared. And if you don't have that memorized, that's why you have your equation sheet. I forgot to hand them out in lab today, but I have a stack of them in my office that I can bring, that I'll bring up after break.
1,000 kilometers?
Correct.
I thought I said that one, I really won't remember.
Well, 1,000 squared is 1,000,000, right? 10 to the 3 squared is going to be 10 to the 6. And that number is going to be, I don't know, 1.609 squared is going to be like 2.5. So something like 9 million-ish. What do we get?
1, 3, 2, 4, 4, 5, 7, 4, 3.
How about in scientific notation? Give me 4 sig figs.
1.032 times 10.
10 to the 4th? 10 to the,
I don't know.
probably 10 to the 7th. Count how many spaces over to the decimal.
4 on my,
Did you remember to square this one?
yeah.
This 7 seems more reasonable to me.
You're probably right, never mind.
I don't know the other one.
It was 8 on the other one for feet.
But on the other one, if you calculate that one out.
Oh, it comes up to the 7. There you go. And if we're not sure, let's plug it in here and make sure we're getting our squared in the right place. 3.988 times 1.609 squared times 1,000 squared 1.032
Yeah, I got 17.
times 10 to the 7. So probably what happened is there could be an issue with you have to remember to hit the squared twice on there. It could have squared the 1 if you did like over 1 and then hit squared or something like that. It could have squared the 1 and not squared the 1,000. So if you do that, make sure you put it in parentheses.
I did. Can you just take a look at my
Yeah.
calculator?
Let's take a look.
So that number is just 10,324,000.
So that number is right. There's your decimal place. Count 3 over, 3 more. That's 6. 7. No worries. I know at this point I'm going to start going back and forth between scientific notation and normal pretty quickly, and you guys are still getting used to scientific notation. So if you get hung up on any of that, just let me know, and we'll make sure everybody's on the same page there. But yeah, and we should within sig figs we should get the same answer. At least within 1% or so. Right? There are rounding issues, rounding differences, if you round it in the middle or not. But beyond that, they should definitely all be 1 point something times 10 to the 7 or 9 point something times 10 to the 6. 9 something high times 10 to the 6 is really close to 1 times 10 to the 7, right? If we want to do this for volumes, instead of areas, still no difference in the procedure, right? We're just going to be dealing with cubes instead of squares.
Yay.
The reason that it's worth thinking about this is because it really does explain why numbers get so big when you start cubing things. When you start converting units to go from from cubic inches to cubic centimeters, well, it's only a conversion factor of 2.54, right? But it's 2.54 cubed every time you do it. And that's more like 10. So you're going to wind up with your number in cubic centimeters being 10 times bigger than cubic inches. Even though a centimeter is only 2.5 times, or an inch is only 2.5 times bigger than a centimeter. So these cubes wind up showing up and kind of making it so it's harder to justify or to judge whether or not your answer is reasonable sometimes. So if we have a box, again, we'll start with nice, I won't say the nice neat numbers, but a nice clean shape at least.
Good visual.
Everybody knows how to calculate the volume of a box if you have the dimensions, right? And this works as long as you don't have irregular shaped stuff, right? Like we did in lab. When you want to find the volume of something that's irregularly shaped, it gets trickier. We want to know the volume of the box in cubic inches.
So would you just multiply that to get the volume of cubic centimeters and then convert it? Is that one way to do it?
That's one way to do it. You could do 3 separate conversions to convert all of these into inches and then do length times width times height. Or do length times width times height and do one conversion 3 times with a cube. And so if we leave it if we do volume in cubic inches, we get 7.68 centimeters, 12.45 centimeters, 5.56 centimeters, centimeters times centimeters times centimeters gives us our units of cubic centimeters now.
531.62.
And how many sig figs are we keeping?
3.
Just 3.
Yeah.
If we want to put that in cubic inches now, we we know our conversion centimeters to inches. 2.54 centimeters is 1 inch.
So you have to cube the whole thing.
We cube the whole thing. All right, and you can distribute this if you want to. It's less writing if you write it outside the parentheses like that, but you could also just get used to distributing it and say 1 inch cubed, 1 cubed, inch cubed, 2.54 cubed, centimeters cubed. Well, it's not a bad way to do it, to remind yourself that if you do have a conversion factor where one side is not 1, you have to cube the top and the bottom. So it's not bad to keep that in your mind, that this is what you're really doing. And we should get something in the 30 range, I think.
32.5 inches cubed.
So 2.54 cubed is about 10, a little more than 10. So 5 divided by a little bit more than 10 is going to give you something a little bit less than 50. And I was just kind of taking a shot in the dark. I thought I remembered from last year that this example came out around 30. I didn't actually get that close on my own.
Behind the curtain.
It's funny because my memory's not that good anymore, but still I'll wind up doing it, teaching slides, and then I'll write, that number seems really familiar. I think that this is going to come out to be that. I don't always remember it right. If we want to take this and put it into gallons, how would we do that?
Divided by 231.
Yeah. 1 gallon is 231 cubic inches. So 32.5 cubic inches and 231 cubic inches is 1 gallon. Do I need to cube this one?
No,
Why not?
because gallons is already in its
Gallons, this is like acres, right? We already have cubic inches as part of the conversion. So it's already set up to cancel out all 3 powers of cubic inches. We cubed the ones over here because we were using a conversion that only had 1 power of centimeters in it. Right, 1 centimeter for this conversion, so we do the whole thing 3 times. This conversion already has inches cubed, so we don't need to do that. If we did cube this, we'd wind up with gallons cubed, right? And gallons cubed doesn't make any sense.
separates the 6 wall.
Right, yeah, so we don't even know what a cubic volume looks like. Volume's already cubic length. Like, doesn't even make any sense. If you get units that don't make any sense, you might have cubed something where you weren't supposed to. The inches would already cancel. Oh yeah, then we wind up with extra cube. Yeah. We cubed this whole thing, we get gallons cubed on top and inches to the 9th, which really doesn't make any sense, right? So if you pay attention to that, that'll remind you that you don't need to do that. Or just treat it as, remember, I need to cancel out 3 powers of inches. I already have 3 powers of inches. Right?
0.141 gallons. 141.
So, and this is kind of what I mean about the cubes throw off these numbers. If I say 532 cubic centimeters, going from this to 32 cubic inches, that seems like there was a mismatch there, right? But that's because of this cube. If I say 532 cubic centimeters is 0.14 gallons, that also seems too small. right? But it's these cubes that kind of wind up throwing things off.
Because the other part of that question is how about in liters? Would it would just be easier then for us to take it from the 532 centimeters cubed for that exact reason?
Yeah, we already have a number on the board that has this in cubic centimeters.
Right.
And as I mentioned to most of you at some point during lab, a cubic centimeter and a milliliter are the exact same thing. Cubic centimeter gets abbreviated in the health profession as cc's. cc stands for cubic centimeter. It's the exact same thing as a milliliter. So we can show a conversion for that. 532 cubic centimeters. We can write a conversion as 1 cubic centimeter equals 1 milliliter.
And then you just do the other.
Doesn't really do anything, right? Once you know this, I have no problem with you just switching these. You don't have to show this step, right? If we want to get to liters, though, now we're in milliliters, and 1,000 milliliters is 1 liter. .532 liters. Now all of a sudden this makes sense, right? There's about 4 liters in a gallon, which means 1 liter is about 0.25 gallons. So half a liter should be half of 0.25. We're right around that ballpark, right? And put it into everyday terms. If you're a beer drinker, that box is about a pint. Really close to a pint. 537 milliliters is a pint. So
We did see that big.
yeah, there's yeah, exactly. 537 cubic centimeters. Actually, it's interesting, in Great Britain, they actually don't label their beers in milliliters. They label them in centiliters because it saves them 1 character of ink on every bottle that they print. Because instead of saying it's a half liter, instead of saying 500 milliliters, they can just say 50 centiliters. And somebody did the math and decided that that was worthwhile to save the cost of 1 zero worth of ink spread over, however many millions of cans.
Nice.
It's like a public service to get people used to using centiliters.
Yeah, although I don't have a problem with milliliters. Milliliters and centiliters, just don't make me do math with pints and quarts and ounces. All right, let's do a weird volume unit. You Forestry Service folks may have heard this before. Anybody know what an acre foot is?
1 acre.
It's
1 foot down.
Yeah, 1 acre is 43,000 square feet. An acre foot is an acre of area 1 foot deep. So they use it for actually measuring the volume of lakes. Because it gives you kind of an idea of what the volume looks like if you know what an acre looks like. But it also means we can actually we can use that to convert units as well.
So we go foot square feet.
We can go from acre feet to cubic feet if we cancel out the acres and leave the foot.
Foot square feet. Cool.
So if I found a number for Lake Tahoe in acre feet, this is before the drought, but it hasn't changed that much. It's a very deep lake. It's 1.22 times 10 to the 8 acres times feet. If I want it in cubic feet, I just have to cancel out the acres, and I can leave the foot alone.
Okay.
I have a definition for acres that gets me from acres to square feet. Square feet times feet is cubic feet, right? If I have a conversion for acres to square feet, if I have an area in square feet and I multiply it by a depth, That gives me feet cubed now, right?
Yes.
Because we wind up with 3 powers of feet now, right? So really, we can do anything you can do with a variable in algebra, you can do with units too. We can cancel out part of the unit and leave the other part alone if we wanted to. That's the equivalent, we said acres is X and feet is Y. I could cancel out X and then Y just stays where it is, right? That's basically what we're going to do here.
So we're going to do 1 acre on the bottom.
1 acre on the bottom, and 43560 feet squared on top. Do we need to cube this or square it or anything? It's part of the conversion, right? Acres cancels acres, feet stays there, times feet squared. We'll get cubic feet as the result. We get a number of
158,400,000, whatever.
Numbers.
that's times 10 to the, that's going to be bigger than that if it was 10 to the 8 already, and then we're multiplying by another 10 to the 4. Should be more like 10 to the 12? Or 10 to the 13?
5.314.
Oh, I got the wrong one.
Say it again?
Oh, 5.3, oh, I guess it's just 31 times 10 to the 12.
That seems more reasonable. We're taking 10 to the 8 is already 100 million, and then we're multiplying it by 40,000.
So it's just 10 to the 12 feet though, right?
Feet squared there times another power of feet.
How many cubic feet, that's what.
Right, these units work just like variables. So we don't have to cancel out the whole thing. And if we need to cancel out the whole thing and we only have length units, we can just use higher powers of conversions.
And then you can just, then you go to cubic feet to cubic miles. That's just one conversion, right?
And that's just one conversion. Because we know by now 5,280 feet, or we at least know where to find it on our conversion sheet. But we need to do it 3 times. $30-ish? 36?
36.103.
Considering we were dealing with 5 billion cubic feet, that seems like it's too small of a number, right? But
Cubic mile.
cubic miles, think about what cubic miles looks like.
It's a big old box.
Right, so 36, that's close to an even square, right? That's a box that's 1 mile deep by 6 miles by 6 miles. It's a very, very deep lake. It's a lot of volume there. And now all of a sudden this 5 billion cubic feet number starts making more sense when you compare it to that. At the very least, if you have no idea how to visualize it, at the very least, we can look at this and say, well, that's 10 to the 12. When I cube this, this is going to be 10 to the 9. At least. There's a 5 cubed in there too. So that's going to be another 100. So that's going to be 10 to the 11-ish down here. 10 to the 12 on top, 10 to the 11 on bottom. I should get something in the 10s range.
You said 6 miles by 6 miles by 1 mile deep.
Uh-huh.
Yeah.
It is. So
Because you just found the lake is 1,400 feet, right?
1,400 feet, depending on what source. I had it in my head as 1,600, but I'm not sure that that's right. So 1,400 to 1,600, somewhere in there.
Yeah.
That's just one point. But yeah, that's still a third of a mile. Yeah, I can get to, yeah, it's a third of a mile because a swimming race that's a mile long is 1,650 yards. So divide that by 3 and you get a third of a mile. 6. There you go. All right. We're going to take our break. We're going to come back, and I'm going to have you do something with acre feet with Folsom Lake's numbers instead, just for more practice. All right, 10 minutes, so let's come back at 5 till. I'll go get conversion sheets for everybody and copies of the ICA, because when we get through these slides, we're just going to spend the time working on the conversion practice. And that might be the last. It's a pretty short slide deck today because, this is the word problems.
Oh, so we're just gonna work on the word problems right after?
Yeah.
Cool.
So I'm gonna go grab those right now. Nobody grabbed those. I just left them on.
Okay.
There's one less thing. I'm going to do 2 assignments after. You have to answer. I'll teach you how you find it. You can read it afterwards. You just don't come with it. Don't get one.
Are you able to figure out that drawing clearly? Yeah, they already.
Sphere. Sphere is what's going to help. Okay.
Yeah.
So that's here. There we go. So we're using one of these two equations. So that's for the sphere. That's why they give us the so for the volume, whatever I say is. That's just how to start it.
Yeah.
So your volume will be so that should be that. These are the kind of word problems you're going to create for the test, right?
So you only have one word problem like that on the timed part of the test. Those are more like word problems that I'll give you on the take-home part of the test.
Yeah, because this is
So the way I structure the test, 9 out of the 10 parts of the test, so 90% of the points, are going to be pretty straightforward, clear. These are the skills I'm testing you on questions. And there's one problem-solving part.
And my other question for you on this conversion sheet you're talking about, what is SA mean?
SI,
SA. This is for a sphere, SA equals
surface area.
surface area. That's what does that mean?
If you took a sphere and you broke it up and flattened it out, if you took a globe and you made it flat,
Okay.
the area that you would put it on would be, that's the surface area.
Okay. And then does the surface area have anything to do with the volume and stuff like that?
They're related.
They're related, but they're not. Okay.
That
Oh, so the volume is what's inside the sphere.
the surface area is
Okay.
on that. And interesting,
You use
for those of you who've taken calc, if you take the first derivative of the volume, you get the area of a sphere. So for a circle, area is pi r squared, right? And the diameter is 2 pi r.
Sure.
For a sphere, the volume is 4/3 pi r cubed,
Correct.
and surface area is the first derivative of that, which you multiply that by 3 and drop this power by 1, so it's 4 pi r squared. For a 4-dimensional sphere, you couldn't call it volume at that point, but there is a way to calculate that. And then the volume that would make up the surface of a 4-dimensional sphere would be the first derivative of that. Getting to higher powers is weird. Theoretically.
So then, Sean, we're looking at this crazy thing.
Yes. Well, we won't in this class, but if you take upper division math. Turns out that's what a tesseract is. Those of you who've watched the Marvel movies, the tesseract.
Nice. Yeah.
Tesseract is a 4-dimensional analog of a cube. So what a cube is to a square, a tesseract is to a cube. So it's this weird 4-dimensional shape where if you take a cross section of this shape, you get a cube.
Yeah, so basically the shadow of it would be a cube.
The shadow of it would be a cube, which is really, really weird to wrap your head around.
So it's units would be like inches to fourth.
Yes. We don't have ways, that's not how we perceive the universe, so it's really hard for our brains to work in a way to understand what that actually means, but we can do the math to show that it exists, just not in the everyday world that we perceive.
So there is a way of measuring it.
Yes,
Yeah, it'd be like something at a baby
Theoretically.
you're right. So think about if you have if we have a 2-dimensional world that has a little person, a little 2-dimensional person that lives right there.
Okay.
If we picked up that person and moved them over there just by using the 3rd dimension, picking them up and doing that, to them it would appear like they teleported, right? Because they have no perception of up and down. They have no way of understanding what just happened. All they know is they were here and now they're there. Or it could So, and it would look really weird too, because if they can only see 2 dimensions, if you stuck your finger through their world, it would look like a point when you first touched it, and then it would look like the outline of your finger as you moved your finger through it, but they would have no way of knowing what was happening, just this weird thing just growing, and then had this sort of constant shape to it. So when you apply that to a 3-dimensional universe that we perceive, conceivably you could have something interacting in 4 dimensions that we just have no way of understanding quite what it is, but we can do the math for it. It just would look really, really weird to us, look like a wormhole. So if we took this as if this was a piece of paper and we were able to bend it and put a hole in it, you could actually connect right here to right there. It would look like what a wormhole would look like to us, which would be a hole in space that connects 2 areas of space that aren't normally next to each other. Theoretical physics is weird. All right. With that, rattling around in your brain now, let's get back to easier stuff like acre feet.
36 miles.
36 miles cubed. Yeah, we're going to come back to that in a minute.
That's a lot of blue.
It is. That's what's the figure that gets thrown around all the time. It's enough water to cover all of California in a layer 14 inches deep. So that's a lot of acre feet, right?
That's a lot.
All right. Folsom Lake, on the other hand, holds 1.01 times 10 to the 6 acre feet at capacity, which we're nowhere near that right now. I don't know if anybody's seen Folsom Lake lately, but it's a puddle. It just looks like where 2 rivers come together. It doesn't even look like a lake at all anymore. If it was at full capacity, how many cubic meters are there?
Would we go 5 cubic meters? Would we do 12 inches over 1 foot feet? And then 10 meters over inches cubed, and meters over.
Yeah, you can go feet cubed to inches cubed to centimeters cubed to meters cubed. So same conversion we did on this side, on the left side. We just got to get to, so remember, 1 acre equals 43,560 square feet. And that one's exact. That's a definition.
That's the point, right?
So that's area, feet squared.
And is that the abbreviation of acre?
Yes. We don't really use acre very commonly, and even in other parts of the world, they don't really have an equivalent. Maybe hectare. I don't actually know what a hectare's definition is. But generally speaking, if you look at like property and places where they use the metric system, it'll either be in square kilometers or square meters. Square meters for houses, square kilometers for land.
I'm sorry, is that exact?
Yes, this is exact. This is the definition. Don't know where it comes from. Actually, I do know where it comes from. Originally, an acre was defined as the area that one farmer working with one donkey and a plow could plow in one day.
Yeah.
So if you needed enough workers to be able to do your 10,000 acre ranch, you could calculate it from that, just from how many acres you had and how many days you had to plant. So if we've got acre feet, we get to cubic feet by using our conversion here, cancel out acres. And we're in cubic feet.
Nine by 10 to 10.
4.40 times 10 to 10. Like 4.39.
6-1, right? Within sig figs. We're only off by 1 in the last place, so it doesn't matter to me, it's the same number as far as I'm concerned. We got cubic feet there, and we want to get cubic meters. Conversions.
Inches.
Feet to inches. Cubed. Inches. Centimeters. Cubed. So that cancels out feet. Cancels out inches.
Cubed is only constant.
Yes, to remember you cube everything.
.24 by 10 to the
10 to the 9, you say?
Yeah. I'll wait for clarification.
Let's see if that makes sense. We were 10 to the 10, then we multiplied by roughly 100. That would make it 10 to the 12. Then we multiplied by 10, which would make it 10 to the 13. Then we divided by 10 to the 6. For very, very rough estimate. I don't think it's off necessarily. Is anybody getting anything different? Yeah. If we want to know how much bigger is the volume of Lake Tahoe compared to Folsom? Compare. Helps to be in the same units. And this is actually where scientific notation is really helpful. Because we can actually just go back to the acre feet we had at the beginning for both of these. If Folsom is 1.01 times 10 to the 6 acre feet, and
Tahoe is 1.22.
Tahoe is 1.22
That's 10 to the 8.
times 10 to the 8 acre feet. Those coefficients are relatively close together, right?
10 to the 8.
10 to the 8 and 10 to the 9. 10 to the 8 is 2 powers of 10 bigger, right? So roughly speaking, we can say Tahoe's volume is 100 times bigger than Folsom's. Because 10 to the 2 is 100.
Yeah.
Right, just by, all you have to do is, as long as these are close, all you have to do is look at these to figure out how much bigger or smaller something is. And if these aren't close, we can still do it. We just do a little bit of math over here and then compare it to a power of 10 over there. Right, so if we want to do something like how much bigger is the volume, is the diameter of the sun compared to the diameter of the earth? Compare the diameters. If they're in scientific notation, just look at the powers. Say it's roughly 100 times bigger. Odd that it comes up twice, but yeah, I think it's the diameter of the sun is also going to be roughly, it's on here, isn't it? Radius of the sun is 7 times 10 to the 5 kilometers, and the radius of, that's the moon. That doesn't help us. The sun's roughly 1,000 times bigger than the, or 300 times bigger than the radius of the moon.
The conversion to that, to the Earth?
Yeah, we'd want to have to find a conversion for the radius of the Earth, the radius of the moon. All right. We would just have to look that up at that point if we wanted to know about the Earth versus the moon. But once you understand how some of these conversions work, and especially once you understand how you can really quickly do back of the envelope calculations, if you know a few constants, a few points of reference, you can estimate a lot of different things. It won me a free drink at bar trivia one time because I was the only one who could come up with, how far is the Earth to the sun off the top of my head. Well, I don't know that, but I know it takes six minutes, and I know the speed of light. So, on a bar napkin, I very quickly could come up with what that was. I got a free beer out of it because I happen to know the speed of light and that it takes light 6 minutes to get to the Earth.
You're saying I could use chemistry to get drunk.
Getting drunk is.
I'm just saying.
Chemistry is
I spent a lot of time brewing beer, and that's absolutely chemistry. All right. If we go to seminal film here, Raiders of the Lost Ark, got the Golden Idol. Everybody seen this film?
Yes.
Okay, if you haven't, it's on Netflix, and that's part of your homework this weekend. You think I'm joking, but I will test you on that. If we know the density of gold, how much is that idol going to weigh? So, before we get to answering this other question, if we just want to know how much the idol is going to weigh, and let's just say in kilograms, we might need to make some assumptions, maybe do some geometry. How much does the idol weigh in kilograms?
Are you just choosing kilograms because the density of sand is in kilograms?
And that's in grams per milliliter as well. Just to keep things consistent. So, how do we figure that out? Conversions, good. I have to get a little bit more creative because we need to figure out how big the idol is, right? We don't have any measurements for it. And we've got a picture of it next to Indy's head. And roughly that big-ish. We could call it a cylinder, or we could call it a sphere if we wanted for the sake of estimating. Heck, for the sake of estimating, we just call it a cube. Make things really easy, right? Sphere is probably a little bit closer. How big is the radius of this sphere in whatever units you want to use? Maybe it's easier to visualize it as a cylinder. So we say that the diameter is maybe 8 inches.
Sure.
And maybe the height is 8 inches too.
Yeah.
To make it easy. Yes, absolutely.
You like those
Exactly.
numbers.
Like it is.
Plus or minus an inch, right? We'll just do this to 1 sig fig, and then we'll keep track of where our uncertainty is. We're probably not off by 10 inches, right?
You're gonna put a dot there?
We put a dot there, yeah. So what's the volume in, let's do the volume in milliliters, since we're gonna use milliliters to get to grams later.
The volume of a cylinder. Pi r squared h.
Pi r squared times the height.
Yeah.
The area of the base times the height.
401 + 92.
That's in
That's in inches.
Cubed.
Cubed.
401, you say?
Yeah.
So let's just call it 4 times 10 to the 2
Okay.
inches cubed.
So
Seems a
then,
little high when you think about a gallon of milk, right?
16 times 8.
16 pi.
So cut this in half before you square it.
Yeah, 16 pi.
16 pi. Pi is about 3, right? For the sake of doing this in my head. So that's 48 then times 8. Yeah, I guess, yeah, 400 is based on the measurements we threw up there. It's probably not actually, doesn't have a diameter of 8 inches. It's narrower than that. That's probably where our discrepancy is coming in, because we're getting a volume of more than a gallon. That doesn't look like more than a gallon of milk. Wouldn't fit into his man purse if it was more than a gallon of milk, right, in terms of volume. But we can still use this. We'll stick with these because these numbers we estimated first. If we want to know how much it weighs, and we have the density in grams per milliliter, we need this in milliliters, right? Or cubic centimeters.
By 2.54 cubed.
Times 2.54 cubed.
Yeah.
You get like 40 or so? Or no, 40,000?
6,000.
6,000?
Yeah.
So 6 liters roughly. Again, we overestimated the size here. It's not 3 2-liter bottles. Think of the size of it. It's about 1 2-liter bottle. Frankly, it's probably more at close to its size. Messing up that diameter estimate at the beginning is throwing off all our numbers at this point.
Cool.
But that's okay. Why is that?
You guys are completely different on my calculations. When I feel like I did it wrong.
I got those numbers.
I got 65, but it didn't really matter.
You probably missed a squared when you should have cubed, or you plugged it in as just 4 instead of 400.
Okay.
That's probably most likely. If you plugged in 4 instead of 400, that would do it. So if we want to know how much that weighs, assuming it's pure gold, and let's be real, Indy wouldn't be chasing it if it wasn't pure gold. Belongs in a museum.
Would be historically valuable.
Yes. Yeah, let's not sell Indy short. I think of that. So we're looking at 6,000 cubic centimeters, which is really same as milliliters, right? Because a milliliter and a cubic centimeter are the same. And we have a density in grams per milliliter. We want to know what it weighs. Cancel out milliliters and we'll be in grams. Milliliters cancel with milliliters. Get, we're only keeping one sig fig here, get 1 times 10 to the
5.
5, which
I agree.
we wanted to put that in kilograms so we have some frame of reference. Divide by 1,000, right?
115.
So about 100 kilograms, plus or minus 100 kilograms. That's kind of a lot. Does anybody know a quick conversion to go from kilograms to pounds? It's 453 grams per pound, but it's roughly double. Yes, 2.2 pounds is 1 kilogram. So in other words, this golden idol, if it had the dimensions we assumed at the beginning, he's not picking that up. He's definitely not running and jumping across a pit with it in his man purse. It's roughly 200 pounds of gold.
Yeah.
Even if we greatly overestimated that, we've done this number before with more realistic numbers, and he still winds up being something like 80 pounds. It's very heavy.
You're telling me the Indiana Jones movies are fake?
No, right?
Well, you can technically use a whip to knock a gun out of someone's hand.
The numbers we use
True.
are fake.
Wait, that's, you could do that.
80 pounds?
No, you could lift if someone's.
Oh, I couldn't.
Oh,
But
you practice.
Imagine, well, so he needs like a big old bucket of sand too.
Yes, he's also not taking sand out of that little pouch, right? That he's trying to make it weigh the
Full
same.
bucket.
Yes.
Of sand.
We can look at that just in terms of the density. Density of sand is about 3 grams per milliliter.
How much
So gold is roughly 6 times more dense. So you need roughly 6 times as much sand by volume. So yeah, like a 5-gallon bucket of sand to make up for the weight of this football-sized thing of gold.
I think also though, we're like totally assuming that it weighs what's sitting on it in order to, instead of
True.
just being a button that you have to hold down. Like
It's
maybe
true.
you could just put your shoe on it.
It just needs something
You
on
just
it.
need something to push
Yeah.
it down.
We are also debating the plausibility of a movie that ends with, the Ark of the Covenant being opened and ghosts coming out and sucking
And also
Nazi
melting
souls.
a Nazi.
Yeah. So we shouldn't get too bogged down in the realism aspect here, but I will say that The Raiders of Lost Ark is one of 2 movies that Steven Spielberg has said when he was done with it, he was 100% satisfied with it.
What was the other one?
I think it was Schindler's List.
Uh,
So, according to Steven Spielberg, Raiders of the Lost Ark is as good as Schindler's List. I mean, I'm not an expert, but I'll trust him.
Being satisfied with it doesn't mean it's the same as having good one.
That's true. That's true.
It just means that you're happy with what you did.
All right. So if you don't have a copy of the ICA for this week, this is what we're doing the rest of the class. You guys have it here. Got some of these. Pass that around. And on the other side, I will start a stack of conversion sheets for anybody who doesn't have the conversion sheets printed out. So the top half of the ICA is pretty straightforward conversions. There are some irregularities with the sig fig, so don't get too bogged down in that. For instance, there's one problem that looks at, that has fractions involved. Generally, what we're going to do with fractions in this class is we're going to pretend they don't exist.
Okay.
If there's fractions involved, just ignore it and act like there was no measurement taken. And there's some things about like the dimensions of a soccer ball. You can assume that those are exact numbers initially.
Yeah, 27 or 28.
27. So 27 is your top limit, and 27 or 28 is your 27 is your bottom limit. 28 is your top limit. So you can assume that those are hard, exact numbers. The actual measured diameters are going to be different.
Hey.
All right, everybody get a copy of the assignment? And no. Okay. Usually the assignment is that way.
So then, should I just pick one of the numbers?
You go that way maybe with it if you already got a copy. So if you want to cube caret. So when you're plugging stuff in on your calculator, if you don't know where the cube button is on your calculator, caret means raised to the. So if you want to say 5 cubed, type it in like that. So that means shift 6 maybe on the keyboard. Something up there between 4 and 8 on the keyboard.
So because it's the first one just like between 2 numbers, I just say 7.5 and just do the conversion from there.
No, convert both ends. Because that's, if we're looking, it says the soccer ball has to be between these measurements, right? So you need to know what the bottom limit is and what the top limit is. So convert 27 and then convert 28. And feel free to turn the desks around, work in groups. If you want to work on the word problem, since that's what we've been practicing, and you're in groups or in a room full of other people, the top half should be pretty straightforward. So you might want to work on the bottom half that's a little bit trickier while you've got other people around and while I'm here with you.
I'm in word problem. I'm just going to work on the word problem together.